Good morning, students. Today we are going to discuss about the periodic table and the blocks in which it has been divided. Now, the periodic table is been divided into S block, P block, D block, and F block, depending upon the last electron which will enter either the S subshell, P subshell, D, or F, right? So we will just have a view on this on the board. You can see here that I have just drawn a schematic representation of the periodic table. On the extreme left, right, here we have got the S block element, right. On the extreme right, we have the B block element. In between the two, we have the D block element, and at the bottom, right, we have got the F block element. Now, students, now this S block elements, right, also known as the representative elements, right, and they have the general configuration NS12. That means their S subshell will be getting either 1 or 2 electrons, right, and depending upon whether the S subshell is getting 1 or 2 electron, the S block will be divided into two groups, right. One is the group 1, another is a group 2, alkali matter and alkaline earth matters, right, students. So S block elements, they have the general configuration, outermost shell configuration NS1-2, either 1 electron or the 2 electrons will be filled up. Now coming to the P block elements, on the extreme right, we have the P block elements, right, and they have the general outermost shell configuration as NS2 N P1 to 6. Now what is N here? N here is the principal quantum number, that is the outermost shell, right. N S2 N P1 to 6. So you can see that here S subshell is completely filled up, but there will be gradual filling of 1 to 6. So depending upon whether the P is getting 1, 2, 3, 4, 5, 6. The P block elements have got 6 groups in it. Right? Now, and groups are group 13, group 14, 15, 16, 17 and 18. Students, here the dotted line just discriminating the group 18. Now this group 18 is of noble gases which has got the complete configuration NS2 NP6, right, and since the outermost shell is getting filled up in the P subshell, it will also come under the P block element, right. Now the S block and the P block, these two block elements are known as the representative elements. Right, students? Now, in between the S block and P block, you can see that the D block is present. So, D block elements, right, they have got the general outermost shell configuration as N-1, D, 1 to 10 and NS 0 to 2. So, student, here N-1, D, right, D subshell will be filled up gradually by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 electrons. So that's why in this D block, right, every series will contain how many electrons, how many elements, 10 elements, right, and there's a and the N shell is the shell number, or it is relating with the period number, right. So if N is 4, right, this will be D will be 3D, right, student. This is there. So the D block elements known as the transition element, right. So here the placement of the D block element is between S block and the P block. Is a transition from the uh, S block element, that is the electropositive elements, to the less electropositive elements, right, or we can say more reactive elements to comparatively less reactive elements. So this is a transition, a change from S to P, right? Reactivity way. So this D block elements are called transition elements. Now at the bottom, you can see this is the F block elements. So these elements were discovered later on, right? So there was no place here. So they were placed at the bottom. Otherwise, they could have disturbed the whole periodic table sequence. So F block elements known as N minus 2, sorry, are known as inner transition elements, right? So they are the inner transition elements. So I'm writing here inner transition element, and they have the general configuration n minus 2 f1 to 14 n minus 1 d0 to 1 and ns2. Hence structure will be completely filled. Then come d will either have 0 or 1 electron, and f subshell will have the electrons from 1 to 14. That means there will be gradual filling of the electrons in the F subshell, and since the maximum 14 electrons are possible, so both it consists, F block consists of two series. So both series will comprise of the maximum of 14 elements, right students? So this is the schematic representation of the periodic table, just showing the position of the different blocks, right? So this is the schematic representation of the different blocks in the periodic table. So just get it drawn in your notebook, right students? Students, just we have seen the schematic representation of the periodic table mentioning the different position of the elements based on the blocks, right? Now we are going to discuss individually the S block elements, P block, D block and F block. So we'll begin with the S block element, right? So the S block elements, they have got the general electronic configuration, so NS1 or NS2, right students? So if it is NS1, right? So NS1, that is the outermost electronic configuration, will be of alkali metals, right? And if it is NS2, this is of the alkaline earth metals, right? Now we can have the alkali metals like lithium, sodium, potassium. Now if I write the configuration of lithium, so lithium atomic number is 3. So when I write it, it will become 1s2, 2s1. So here you can see its outermost configuration. This is student outermost configuration, okay? So it is lithium 3 becoming 1s2, 2s1. So how many electrons are there in the valence shell? It is 1. So it is configuration relating it ns1. So if you write simple of sodium also, so we can have neon condensed form. I'm writing here neon, that is 10, right? And second shell will completely get filled. So it is 3s1. So neon is 1s2, 2s2, 2p6, right? And this is 3s1. Similarly, you can write down the configuration of alkaline earth metal also is ns2. Let us write with of the beryllium here. So beryllium is 4. So when you write down the configuration 1s2, 2s2, you can see that its outermost configuration is coming 2s2, right? In the same way, you can write for magnesium also. Magnesium is 12. So as I have written neon configuration condensed form, it is 10. It has got the second shell completed up. So it will have now 3s2, right? So the alkali metals and the alkaline earth metals, there is a gradual filling of S subshell. That's why they are coming under S block elements, right? Now second, right, since they have got only we can say the one electrons, so they will show we can say they have a tendency to lose this electron, one electron, right? And by losing the one electron, they will get plus unit of charge, plus one, right? So we can just write down here that they are electropositive. So electropositive in nature, right? So they are electropositive in nature and are reactive. Now in their respective period, right? Lithium coming in the second period, sodium in the third period. They are going to be the most electropositive in their respective period. So most electropositive in nature in their respective period. Right? Now, third is that they are soft metals. Right? They are the soft metals. That means that they can be easily cut down, or they can be easily worked on. Right? These metals can be easily worked on as they are the soft metals. Right? So they are soft metals. Now just think about the melting point and the boiling point of these alkali metals. Whether the melting point and the boiling point of these alkali metal will be high or it will be low. So since they are soft metals, so they will have low boiling point and low melting point. Right, students? Next, coming to their ionization enthalpy, they have low ionization enthalpy. Students, they have got low ionization enthalpy. Now, what is ionization enthalpy? You must have gone through in class 10. If not, right, or if you don't remember, okay, and if you have not gone through it, now let me tell you what is ionization enthalpy here. Ionization enthalpy, it is the energy. Enthalpy term is related with the energy content. Okay, so and it is the energy which will be involved, right? Which will be required to get the outermost electron removed from the atom, right? So here the outermost electron, right, in the alkali metal is 1. Here it is 1. Here it is 2. So 2 electron, that means 2s1, right? Any one electron. So it is the amount of energy which will be required to remove the outermost shell electron, right, from an isolated gaseous atom, right, to form a cation. So whenever an electron will be removed, it will form a cation, right? So they have got low ionization enthalpy, and that's why we are saying forming a cation. Cation gets the positive charge, so it is electropositive in nature. Since they have got low ionization enthalpy, right, that means with giving little amount of energy, less amount of energy, that electron can be easily removed, right? That's why they are reactive in nature. So low ionization enthalpy and reactive in nature. This reactive we have discussed in first point also. So we can write there also, here also. Most electropositive in nature, that's why they are reactive in nature. They have got low ionization enthalpy and are reactive in nature. Right, student? Now the right fifth point. They give characteristic color to the flame. It means that when the S block elements they are heated in the flame, they will give a characteristic color to the flame. For example, sodium gives the yellow color, right? So every S block element, whether it comes to the alkali metal or alkaline earth metal, will give a characteristic color to the flame, right? Now the next point which you will write is that they are a very good reducing agent, right? The S block elements have a characteristics that they are very good reagent or reducing reagent also. So the next point is they are good reducing agent. Right. Now reducing agent means that they causes oxidation, right? They show oxidation, they lose electron and get that electron available for the other species or other element. So that's why they are good reducing agent. Now this again reducing nature will depend upon their ionization enthalpy, which leads to the electropositive nature. And most of the compounds are ionic in nature. Right, students? So the S block elements, they mainly form the ionic compounds, right? Let it be sodium chloride, potassium chloride, sodium sulfate, potassium sulfate, right? Though the magnitude of the ionic nature will vary when you move down the group. So we are going to study in detail when we will go through the S block elements. Now till here, till now, you have to just remember that the most of the compounds that they form are ionic in nature, right? So these are the main characteristics of the S block element. So get it noted down in your notebook. Students, just now we discussed the characteristics of S block element. Now we will continue ahead. We will discuss the characteristics of P block element. As we have seen in the schematic diagram, that the P block elements are placed in the extreme right of the periodic table, right? And they have general electronic configuration of Ns to Np1 to 6. So since they are involving the 6 electrons filled up, right, in the p subshell, so there will be 6 groups in the p block element, right? So here in the p block element we have discussed that the general electronic configuration, the outermost one which is going to be filled up, right? Generally we write it outermost, or you can simply write down general electronic configuration, right? It is Ns2 Np1 to 6, right? Now there will be gradual filling of these subshells. So it will include from group 13, right, 14, 15, 16, 17 and 18. So from group 13 to group 18 will be included in the P block element. Now let me mention here one thing, that in group 18 the first member is 1s2. Now this is which element, student? This helium, right? Now you can see that it has got the s subshell completed. It has got the last electron entered in the s subshell. So why it has been placed in the P block? It should be present in the S block element, right? Along with the we can say group 2 element, which has got 2 electrons in the outermost shell, S subshell. So students, can you tell me that why it has been not been placed in the alkali along with the alkaline earth matters in the S block? Why along with the P block, right? So students, the answer is that it has got the completely filled outermost configuration, right? It has got S subshell completely filled up, right? For the outermost shell, n equals to 1, right? So that's why the group 18, it has been placed along with the group 18, which has got the completely filled outermost shell configuration for every period, right? If we talk about n equals to 1, here it is helium. Then we talk about the n equals to 2, there it will be neon, right? 2s2, then 2p6. This second shell is completed for the neon, right? So that's why the helium has been included in the P block, because it has in the group 18, as it has got its outermost shell configuration completed up, right? Now second is that this group include, this is the group which will include, only group which will include metals, non-metals, as well as metalloid, right? So this group element includes both metals, non-metals, as well as metalloids. Third, right students, so here the third point is that these elements have got high ionization enthalpy, right? And that's why they are not going to lose the electrons readily, right? And what happens that they are termed, we can say that they are being the electronegative elements, right? So p block elements, they are, we can say, high ionization enthalpy, right? And include ionization enthalpy, right? And fourth is mainly electronegative nature. Now, what is electronegative nature? It is the tendency to just pull the shared electron pair toward itself. We will discuss in just later ahead in this unit only, right? They have got high ionization enthalpy. They are mainly electronegative in nature. Now, students, the high electronegative nature will lead to the non-metallic character. Non-metallic nature, right? So the electronegative nature is in group 18. So in this p block will increase, right, from group 13 to group 17. Now group 18, though it is included in p block, right? Then also, since they are not been discussed, right? When we talk about the electronegativity or any other properties, right? We are going to study the group 18 separately, right? So since definitely, since they have a completely shared configuration, right? So they will have some properties, or they will have some different properties, right? There will difference in the properties also. So mainly the electronegative nature, that means the tendency to pull the electron cloud toward it. As a result, there will be the negative charge duller, right? So they show mainly means the non-metallic nature, right? So when we move across the period from group 13 to group 17, right, the electronegative nature is going to increase, right? And when we are going move down the group, that time the electronegative nature is going to decrease, and we will get the metallic nature obtained when we move down the group, right? So non-metallic nature, we are, it is going to increase in this way because electronegative is going to increase, right? And it is going to decrease. This is the increasing trend, right? And this electronegative nature is going to decrease when we are moving down the group. This arrow is showing the down the group, right? Now fifth point is the oxidation state. Now the oxidation state, it is variable. They show more than one oxidation state. So in the S block, it was only +1 for alkali metal, and alkaline earth metal shows +2 oxidation state. Whereas in this case, the P block elements, they show the oxidation state which is variable, right? Now the sixth point is the nature of the compound formed. Nature of compound. So students, here we will get both ionic as well as covalent. Right? So P block element, right, it comprises of 6 groups, group 13 to group 18, right? Second, this is the only group which will include both metals, non-metals as well as metalloids. They have got high annihilation enthalpy, right? So a tendency to lose electron is less. They are mainly electronegative in nature, which is showing the non-metallic nature, right? The non-metallic nature, we can say it is going to increase when we are moving across the period from group 13 to group 17, and is going to decrease. The non-metallic nature is going to decrease, right? When we move down the group, right? Or we can say the electronegative nature is going to decrease when we move down the group. They show the variable oxidation state, and the nature of the compound which they are going to form is both type, that is ionic as well as covalent. Students, just get the thing noted down. Now students, we will discuss the characteristics of D block elements. Now the D block elements are also known as the transition elements, and they are having the general valence shell configuration or outermost shell configuration, general valence shell electronic configuration as n minus 1 d 1 to 10 ns 0 to 0 to 2, right? So here this, if this is the outermost shell, right, and this is known as the penultimate shell, right student? This is penultimate shell. This is the outermost shell. This is just one less to it, that is the anti-penultimate. So this is known as a penultimate shell. For example, if we are writing for the chromium, right, that is how much? That equals to 24. So in that case, here we have argon 18, right, and we know the configuration. It is how much? 4s1 3d5. So here student, N is the outermost shell, and third, this 3, it is the penultimate shell, right? And you can see that here, that this 5, so it is ranging between 1 to 10, this 0 to 2, it's 1 here. So in the D block elements, there is a gradual filling of the D subshell, right? And depending upon whether which penultimate shell is being used, right? It will be the D block element is divided into 3 series: 3D series, 4D series, and 5D series. Now, second is depending upon the D subshell involved, right? It will be known as 3D series, 4D series, and 5D series. If the 3D subshell will be involved in the electronic configurations, will be 3D series, 4D series, and 5D series. The D block elements, they are known as the transition element. Now students, why they are known as transition elements? Because they are forming the bridge, right, between the group, we can say forming a bridge between the group 2, which is less, which are more reactive elements, and the group 13, 14, which are less reactive, right? Again, I'm repeating, they are forming a bridge between the more reactive S block elements, group 1 and 2, group 2, and the less reactive of P block, that is group 13. So there is a change in the transition between from the reactive group 2 element, right, to that of the less reactive group 13 elements of the P block. That's why they are known as the transition elements. Now these elements, right, these D block elements, they are hard metals having high melting point and boiling point. So students, they are the hard metals having high melting point and the boiling point. Now next is that these transition elements are the D block elements, they will be known as 3D transition series, first transition series, second transition series, and third transition series. Now the next is they mainly form colored compounds. So students, they form the colored compounds. Sixth, they show variable oxidation state. Now the variation in the oxidation state will depend upon their electronic outermost shell electronic configuration, that is the number of electrons which will be available in the outermost shell. Now the next is they show elements of this group show catalytic properties. That means they act as a catalyst, right? You have heard about nickel, which is used as a catalyst in dehydrogenation of oil. So in the hydrogenation of oil, we use nickel as a catalyst, right? Secondly, we uses iron as a catalyst when we form the ammonia formation. Needs the iron as a catalyst. So many other catalysts are also there, right? From this block. Now, eighth is they show paramagnetic properties, right, students? So their compounds are paramagnetic in nature. What does it mean? It means that they will be attracted toward the external magnetic field. That means they have got the unpaired electrons, right? So these were the main properties or main characteristics of d block elements. So students, just go through it and get it learned also, that what are the characteristics of s block, p block, d block. Right now we are left with the f block element. Good morning, students. Today we are just continuing our topic, that is the characteristics of S block, P block, D and F block elements. We have discussed in our last class that the periodic table is divided into four blocks: S block in the extreme left, then P block in the extreme right, then we have the D block which is placed in between S and P block element, and the F block which is placed at the bottom of the periodic table. Now students, we are going to discuss the characteristics of the F block elements. As a name is suggesting that here the last electron, right, will enter in the F subshell. So accordingly it will be known as the F block element. Now the F block elements, they are known as the inner transition series. Now students, why they are known as the inner transition series? Because they are placed, their actual location was supposed to be in the transition, in between the transition series. But if they were placed over there, so it could have disturbed the whole periodic table, as they were discovered later. So without disturbing the periodic table, right, they were placed at the bottom of the periodic table. So students, F block element consists of, or we can say F block element has the electronic configuration. So their general valence shell electronic configuration is n-2 F 1 to 14, n-1 D 0 to 1, and ns2. Now students, here n is the outermost shell. Here n-1 denotes the penultimate shell. That means a shell just one less than the outermost shell, right? And the n-2 indicates here the anti-penultimate shell. So this is the anti penultimate shell. Here n-1 indicate the penultimate shell, and this is the the ultimate shell, that is the outermost shell. Now students, here there will be gradual filling of F subshell from 1 to 14. That's why this group is known as, or this group of element is known as F block elements. Second is the F block element. It consists of two series, right? We have got here two inner transition series, and they are known as the lanthanoids and the actinoids. So it consists of two series. Now the series which is just following the lanthanum, right, is known as lanthanoids. And here will be gradual filling of 5F, right? So there will be gradual filling of 5F subshell. Whereas the second series, which is following the actinum, is known as actinoids, and there will be gradual filling of 6F subshell. Now students, just have a look on the thing that if we have n equals to 5, or here if we have the outermost shell to be 6, right, it will be 6s, 6 it is, then this will be 5 and that is going to be 4, or if it is 7, right, it will be here 6 and that is going to be there 4. So students, here, right, just have a look on the configuration properly, right, and we are just going to discuss again that about the lanthanoids and the actinoids. Students, just as I said now, that if we have here, this is the 6s, right, that time this is going to be 5d, and this will be the 4f, right. So in the lanthanoid, just have a correction here, that we have got the gradual filling of the 4f subshell in lanthanoids, and in case of the actinoids, we have got the gradual filling of 5f subshell. Now students, here the lanthanoids, right, here only one element is radioactive, and that is known as promethium, right student, that is promethium. Whereas in actinoids, the complete series, right, is of the radioactive element. So here in lanthanoids, I'm just showing in this way, only promethium is radioactive, whereas in actinoids all are radioactive. Here the we have in actinoids, we have uranium, plutonium, right? All the radioactive elements are present in actinoids. Now we will just move ahead. Now here, lanthanoids and actinoids, these both elements, right, they have high melting points, and they have high density also. Fourth one is that the radioactive element, these elements, they form complexes which are colored. Mainly they are colored compounds, right? And next is that they show the variable oxidation state. As you can see that they are going to have more number of electrons in the f subshell, right? So depending upon that outermost electrons, right, they are going to show the variable oxidation state, right? And just get these points noted down. Just fifth point is, again I'm telling it, you have to write the fifth point as the it has these elements show variable oxidation state. So students, just get the points noted down.